Okay, thank you very much for being here. My name is Jan Hüvel from company Coolux GmbH in Germany. We are developers and manufacturers of Pandoras box media server, which is the little black unit to my right-hand side, your left-hand side. We are showing our new version 4.7. We have been doing a lot of developments in the past year, and one of the core features besides the stereo 3D that we mentioned in the documentation, which I will come back later, since there's one important thing that we needed to look at first over the past years. The main thing is live input and video synchronization. As we do deliver a server and also a playback solution for as a software to our clients that run our software on any kind of hardware or PC, most people use standard graphic cards, and standard graphic cards run DVI or VGA, but this signal is unsynchronized. It runs by itself. It has its own time and own beat. It's independent from the video rate or from a video input card. This leads to an undesired effect that happens here and there. A little dropout, a little stutter, a little jitter, and that for corporate shows or live events can make a CEO very unhappy if they're very picky about image quality. So we spend a good year about looking into an algorithm to compensate for that and to calculate the ideal frame, even if we are dealing with different kind of frame rates. So we call this new technology fluid frame. It's an input rate cross conversion algorithm that allows us to mix within one output or two outputs different formats: 24, 25, 29 and 7, 30, even 59 and 30 FPS at the same time, no matter what the output rate is. Of course, an ideal scenario is always when I'm close to my output rate. So if I'm running 50 Hertz on my output display, it would be ideal to either run at 25 or 50 Hertz as video or input signal via SDI or DVI input. Of course, due to the fact that in a lot of situations this is not possible to set up, or it's difficult to set up depending on the display, we have come up with this algorithm that you can turn on, and it smoothes out the motion. I will show you this in a little moment on the other unit if I will have these 30 seconds to show you. I know the clock is ticking. The other advantage that we got from that is a little side effect, but it's a big one for us. In some occasions, people like to use, for high-end video playback, 50p or 60p playback, high-frequency playback for super smooth motion. And this algorithm allows us to do that as well, since in this way we can play back the high frame rates according to the graphic card's output frequency, no matter what the hardware is. We can show you this live on our booth. We have HD SDI cameras set up to really show you the real thing, so that I'm not just vaporizing too much hot air over here. Okay, that's one of the things. And to come to stereo 3D has always been a big part of Pandora's box, since all the layers are rendered in a 3D space. And we had the request to do live 3D from a live camera rig. And this needs a synchronization of the left and right eye, and that's where fluid frame allows us on an LED processor like the WinVision Vol, for example, to have perfect sync between the left and right eye. We did a test 2 weeks ago here in London, and it looked awesome. Unfortunately, the wall is not here, so I cannot show it to you. Hopefully at LDI we'll be able to show it to you. Next thing, we have worked on our warping and warping engine to make projection and masking easier. That comes in place where you do architectural projection or projection onto sets. If you want to mask something, some people use Photoshop, take a photograph and try to mask something. They're giving you a quick view at how the warping is done. For example, if you want to project on a building, the warping allows us now to directly warp a texture and correct it. So the artist only needs to create, based on a photograph, the content, and then it can be warped onto the real surface almost instantaneously. And if there's particular parts, since what we're seeing here, this would be the output of a projector, I can switch to a mask mode and start drawing on my canvas directly. And as you can see, if this is a part of the scene that I do not want to have, oops, that's a little bit big, I could just mask it out and export this as a mask into Pandora's box directly. The key to this is, one little feature is by dragging everything around. It's not Photoshop, it's not 2D drawing, it's drawing onto a warped surface. So it's a painting tool that adjusts, and even you can see here the cursor always deforms correctly. So when you're watching on the screen, if it's deformed, it always follows the shape. That's another key benefit of the new version. That's the live screen masking. Of course, there's some new enhancement on the warping technique, that every individual point that can be increased live, so we can change the resolution at any time to have more grid points up to 99 by 99. And every individual point, we can move them individually, offset them from the entire thing, go back to the main FFD, the freeform deformer, or we can rotate that selection. So this is a very easy tool to quickly adjust any kind of warping scenario onto any surface. Oops. Yeah, there we go. The last thing that I'd like to show you is that's something that one of our clients brought up. They wanted to do a live visualization in WYSIWYG. So we put our heads together, and since Pandora's Box in this version allows a multi-server preview, so in our software surface, which is also available as offline editor, you can preview as many servers or playback products from us within a single software without having any physical device attached. And this, within a single preview space, can be streamed into WYSIWYG via an external capture card to be pre-programmed with lighting at the same time. You can see a demo on our booth to see this more in depth. I have a little video if I still have time to show you that.
If it's very, very quick.
It's super quick. Okay. Just to give you a little impression, and then I'm done. Promised. So this is basically the WYSIWYG, the setup. Here you see the individual layers. And here's the whole thing with video mapped onto the LED screens. On the left side, you see our interface, and on the right-hand side, you see the video running in WYSIWYG on moving truss or moving scenery scenarios. So this can be used for pre-visualization or pre-programming. I think that's it. I could keep going, but I think I don't have much more time.
Yeah, we'll just do some questions.
Yep.
Just so I can be clear on this, because I'm not so much a media server expert, but when you say you can do 3D,
yes.
Do you mean so as in you could do have a wall display and people wear the specs?
Yes.
And it does that in real time?
Yes. Every layer sits in a 3D compositing space. We can offset both outputs and spread them across multiple projectors and slice the perspective. That means that we can do a stereo composition with multiple layers, objects, videos that are even 2D content, bring them into a 3D space and have them floating in the air. That's one way of doing 3D. We can also input to that classic side-by-side or checkerboard videos that run inside that 3D world at the same time, or even take live feeds into that, or 3D live feeds.
Cool. Any other questions?
How many outputs can the server support?
The servers do 2 each. Our playback solution, the software does 1, and you can scale them over network as many as you like. And also the fluid frame, the sync, is maintained over network across all systems.
When's it going to be ready for shipping? Is it
pretty much after the show.
Okay. And a rough price, do you know? Rough price? A rough price. How much?
How much? Since we have a variety of options that you can buy it starts at 700 euros and goes up to, I think, 40,000. So it depends the input card options, the hardware models. Did you have a large RAID array or not? So we have lots of options for our clients.